Hello, we're back continuing from that theory of everything video. And before getting into the life part, I think we should probably cover a real big part, and that is relating to the quantum vacuum and the Standard Model. And what really gave us the atomic bomb, your credit cards, transistors, endless stuff that we take for granted nowadays, is an equation put together by Edwin Schrodinger back in the 1920s called the Schrodinger Equation, which is the main equation for quantum physics. And its predictions have never failed. Its mathematical exactness has just been mind-blowing throughout scientific investigation of how things form. And this Schrodinger equation had an aspect to it that made scientists very uneasy. Some of the first quantum physics people, Niels Bohr and Schrodinger and numerous other scientists, didn't like a certain aspect of the Schrodinger equation, which says that if you have a bunch of potential ways of doing something, they are part of the equation, and it suggests that these many different ways of doing something were actually real. So if you had 20 different ways of putting something together, the Schrodinger equation included all those ways. And so they didn't like the idea that all of those ways of doing something were real. So they said, well, all of those things are in what you call a superposition of what could be. And as soon as you relate to the 20 things that you could do and choose one of them, all of the potential 20 ways that it could be done collapse into the thing that you were doing. So it becomes your observation or your action that determines how all of the 20 ways are going to collapse into the thing that you're actually doing. So they made up this story that we, by observing or measuring, collapse the wave function of the 20 possibilities into the one possibility that we end up seeing or doing. Although they felt a little uneasy about that, because the equation itself was saying that all of those 20 possibilities are actually true, that they exist, which would mean that there are all these parallel universes. And they said, well, they can't be all these parallel universes because we don't see them. So they made up that story called the Copenhagen interpretation, called the collapse of the wave function. But really, scientists were never really that confident in that explanation, because they felt like there was just something wrong with it. They didn't like the idea of the parallel worlds, but they didn't like the logic of the Copenhagen interpretation, which means that you or I choose among all the many world possibilities, and as soon as we choose, all those possibilities collapse into what we just chose. Along comes this scientist named Hugh Everett, who came up with a theory that he called, well, he didn't call it that, but they ended up calling it the many worlds interpretation of quantum physics. And Hugh Everett said that all of those 20 possibilities of what we could do are actually real. They are in parallel. But we don't observe that. So why don't we observe that? Well, Hugh Everett wanted to stick with that Copenhagen interpretation, but later on, years after he died, And they all made fun of Hugh Everett's many worlds interpretation, even though it was following what the Schrodinger equation actually says, that those worlds are real. So it wasn't until like 20 or 30 years later that they discovered what they call decoherence, which basically decoherence is saying that all of those 20 possibilities are real, but they decohere into what we actually see, but it has nothing to do with us making them decohere. So an example that David Deutsch, who's a famous computer scientist, and he's been working on quantum computing for a long time, that David Deutsch loved Hugh Everett's idea of the many worlds interpretation, and actually cosmologists love that idea nowadays too. And so David Deutsch said, well, actually you can see the many worlds, and an example of that is the double slit experiment, where it brings in the notion of subatomic particles or even atoms have a wave quality and a particle quality. They call it the wave-particle duality. So that if you, say, fired a stream of marbles through a single slit and recorded where they hit on a back wall, you would see one line for where the marbles hit on the back wall. If you add a second line and fire the marbles through the two slits, you see two lines on the back wall. I'm taking this from Fred Alan Wolf's Captain Quantum explanation for the double slit experiment. So when we go to waves, if you flow waves towards a single slit, you see on the back wall one line of intensity where the wave hits the wall. But if you fire the wave at the two slits, when they go through the slits, they start crisscrossing each other, and you end up with a bunch of lines on the back wall called an interference pattern. Now this interference pattern is what David Deutsch calls the many worlds. But scientists were really, we're going to play around with this. So what they did is, what happens if we fire a stream of electrons, say, or a stream of photons through the slit? Photons are kind of like the marbles. They're particles. So they fire the stream of protons at the single slit, and they get one line on the back wall. Then they put the two slits up, fire the stream of subatomic particles through that, and they get an interference pattern on the back wall like they got with waves. And they thought, now wait a minute, the marbles only ended up with two slits on the back wall. Electrons are things, they're particles, so they should only be giving us two slits. What's this deal with the interference pattern that we associate with waves? So I said, okay, we're going to try to look and see what's going on. We'll fire electrons one at a time through the slits and see what happens. Well, when they fired them one at a time through the double slits, they end up, after a few hours, with an interference pattern on the back wall, which really confounded them. So they said, okay, we got to look real close and put a measuring device by one of the slits and see what's happening. So then they fired the electrons at the two slits, and when the measuring device was there, they only saw two slits on the back wall. What? Just by putting a measuring device there, we have changed the whole operation, so we no longer have the interference pattern. We now have only two slits on the back wall. So the Copenhagen people that were into collapse of the wave function, that said when you look at the 20 possible things you could do, they all collapse into the thing that you are looking at. And so they use that story to say, well, when we put the measuring device by the two slits, that measuring device caused a collapse of the wave function, so that we only see two lines on the back wall when firing the electron one at a time, rather than, say, 20 lines that we had seen before. Now, that was using the Copenhagen interpretation, collapse of the wave function, that just by observing, you collapse the wave function, scratching our nose again. So, but the many worlds interpretation that David Deutsch was promoting, saying that the double slit experiment shows you the many worlds. So if you use the many worlds interpretation of quantum physics and say, okay, we have 20 lines on the back wall from firing the electron one at a time, and what we see on the back wall, according to Deutsch, the 20 lines, is actually the many worlds. Well then, how do you explain that when we put the measuring device there, you only see two lines? According to the many worlds interpretation, it would say, well, you actually need 10 of you to see the two lines. So you would see all those lines on the back wall if you put 10 measuring devices by it. Instead of seeing just the two lines, you would see all 20 lines. The same can be applied to pictures they have of one particle, say, in 1,000 places at the same time. You see 1,000 dots. And you say, well, how in the world can that be? One particle in 1,000 different places. So you go look, and you only see it in one place. So using the many worlds interpretation, it would take 1,000 of you to see that electron in each place. And what you were looking at there with the 1,000 dots for one particle, that is the electron in 1,000 places at once, you were looking right at the many worlds. So in that sense, we actually do see examples of the many worlds interpretation of quantum physics. We don't see it all the time, or we rarely see it. So with that in mind, I'd like to go right back again to the Big Bang theory that we were talking about before, and say that using the many worlds interpretation idea, at the point of the Big Bang, endless universes popped into existence, of which we see one, ours, and they're all concentric to the point of the Big Bang. So you still have the sphere, but that sphere has endless universes in it that we don't see. That would be the many worlds interpretation of quantum physics. Explanation for the many worlds that could have started at the point of the Big Bang. And I have a phone going off again that seems to always come in on these talks that I'm giving. So we'll just count that as music. Quite different from the cicadas that are blazing away right now, but not real strong under the trees we're standing. So anyway, coming from that many worlds interpretation, I'm going to move into how we could possibly have life occur as part of this theory of everything. I would refer you to a great video that explains this stuff beautifully by this guy named Chris Fields, F-I-E-L-D-S, and the video is called What Are Our Bodies? And in that video, he basically takes you through how life arose on this planet from one cell, and it was the last universal common ancestor, L-U-C-A, Luca. And in that video, he explains how all the life on the planet came from one cell, and he uses that as an analogy to your zygote. And he explains how the zygote divides and the DNA splits and the RNA splits, the membrane splits, and the cytoplasm splits as the cells divide. So the cytoplasm is the same, continuous. The membrane is the same membrane, and the DNA RNA is the same DNA RNA when the cells split. And so he describes how your skin, which is our membrane, and the membrane around your 404 trillion cells is continuous. That all the membranes in your body, all the cytoplasm in your body is continuous from the zygote. And that, which is pretty hard to get a brain around. And then he uses that zygote example to also say that LUCA is just like the zygote, and that all the life on the planet came from LUCA, and 99% of the life on the planet is bacteria, and 1%, in his video he says 90% is bacteria, and 10% is the tree cell or the human cell or whatever, the grass cell or whatever. So it's kind of hard to believe that 99% of your body or a tree's body is bacteria and only 1% is human cells. Quite amazing stuff, and it all evolved from LUCA with continuous membrane, continuous cytoplasm, and continuous RNA DNA, which is really out there. So that I advise watching that beautiful video by Chris Fields. But as far as what was happening with the LUCA cell, how did that start? Well, in his video, they have at the center of the LUCA cell the words combinatorial chemistry. Well, that just shows that they don't really know how the chemicals that ended up forming that cell came together to make the cell. They just know that it came from these certain chemicals, RNA of which was one, phosphates to form the membrane, and salt water to form the cytoplasm. But what I am fascinated about is, since the subatomic particles waving in and out of the quantum vacuum form the atoms that form the molecules that form the cells of life, what is the emergent rule for that? Well, they don't know how things emerge. That's one mystery that they have. They know the ingredients that go into making something emerge from one thing to another. They know the ingredients that make a molecule of water go from, say, steam emerging to water, or water emerging to ice. They know the molecules that cause that and the atoms that are happening with it, but they don't know exactly how that happens. So as we're moving along doing this or doing that, we're constantly being remade by the subatomic particles waving in and out of the vacuum from the vacuum, waving in and out into the atoms that make our molecules, that make our cells, happening thousands of times a second. So you might wonder, let's see, the subatomic particles support my growth. Where's the information? In other words, how do the subatomic particles know to arise and disappear into the vacuum to make the atoms that make the molecules that make our cells. It seems to me that the information is in the quantum vacuum, which is some scientists in the New Age world have given in to how so much of our new discoveries in science overlap with claims made by religions and different philosophical systems over the centuries. And so they have gone to saying, some of these physicists have gone to saying, well, the quantum vacuum is the spirit world, since it creates all things. Well, that's not scientific, but it's interesting. It's possible that the quantum vacuum is what has the qualities of what they call the spirit world, but I don't know what the spirit world is. So, regarding, say, what's happening in your body, and what your cells are doing, and how that relates to your consciousness. How the single cell creature, which relates to the surround, how does its, and I call it conscious because it's relating to the surround, anything that relates to the surround I call conscious. So, and we don't know what consciousness is. We haven't been able to find consciousness anywhere. We haven't found a field of consciousness. We haven't located consciousness, although they've tried locating a seat of consciousness in the brain. They just don't seem to be able to do it. So the consciousness of the parmesan moving around in the cytoplasm, responding to its environment. How does that consciousness affect the subatomic particles waving in and out of the quantum vacuum to create the atoms that create the molecules that create that parmesan, or for that matter, you and I? And one thing that we know for sure regarding our own bodies is that, say something like stress. Well, we know what stress does to our cells. We know what stress does as far as causing our glands and to create or to send neuropeptides and chemicals like cortisone to our cells as fight or flight mechanisms. And if we continue experiencing that stress, we end up continuing to send those things to our cells, and our cells end up becoming injured, and we can end up contracting disease just because of what's going on in our consciousness. So it seems that consciousness has a huge amount to play with what's happening to our cells, and we know that for sure. So the question then becomes, well, if consciousness is a director of a lot of the stuff that's happening in our cells and participating in health and disease, how does this consciousness relate to the quantum vacuum? Well, now there's a really good question. I guess in my way of looking at things, I hypothesize that our consciousness is on the edge of the quantum vacuum, and that the information in our consciousness is mirrored in the quantum vacuum, and it's mirrored in the subatomic particles that emerge to the atoms, that emerge to the molecules, that emerge to our cells. So in that sense, we are entangled with the quantum vacuum, which is pretty far out. And the reason I even got into this is because of years of investigating what could possibly be happening biophysics-wise to emerge healings of of serious disease, healings that should not be taking place, according to the medical profession. So life, what a mystery. And it's somehow entangled with the processes that actually end up producing the life. And as far as we know, one thing, that life has biophotons. The biophotons are waving in and out of the quantum vacuum thousands of times per second. When those biophotons are gone, the entity, whether it's grass or trees or whatever, or parmesan or us, when the biophotons are gone, we are no longer alive. We are no longer life. Interesting. Somehow, those biophotons waving in and out of the quantum vacuum are in harmony with our living. And it's interesting how auras, which they can take pictures of, how auras, which is like a field of biophotons, how those auras reflect a person's consciousness. I know that sounds pretty far out, but none of us can really hide, because our field of biophotons is mirroring what's going on in our consciousness. Now, I've done a number of videos on meditative stuff that really talk about just what's going on with our consciousness and the way our cells are operating. So there are I think 5 videos out there that relate to that. But this is finishing up my little talk on the theory of everything with one last final thing. So you've heard the statement that everything is one, or we're all one, which sounds like a cute little idea. I always thought, you know, there's some kind of feeling that I have of us being all one. Well, Luca, the last universal common ancestor, which has membrane and cytoplasm and RNA, DNA continuous with every living thing on the planet, that means that we are all one in a really physical way, because we're all part of this great evolving body that happened like billions of years ago of Luca. And there's another way that we're all one. In fact, that every thing in the universe, that is anything made out of atoms, is all one, in the sense that all atoms are entangled on the edge of the Higgs field, which creates all things. So in that sense, we're all one also. And with that, I guess I'm going to close this little talk. And by the way, my name is John Hill. And have a great time feeling all one.